Actually, I have.
Okay.
So we make the possibility to add an arbitrary amount of opponents.
Yes.
And so the winner thread has to guess the values of all opponents. Does
Well,
it not?
since we are also terminating a thread as soon as we guess its number, then it would be rather sort of battle royale where you just the last thread that was not terminated is the winner.
Ah, okay.
But if you want to implement it the way that it has to guess the numbers of all the threads, that's also fine. So it's just an exercise in thread synchronization. So as long as you have something that works reasonably well, it's fine. It's not necessarily to be implemented strictly in a particular way. Especially if you implement it in a more complicated way than the required way, then it's fine.
Okay. Okay.
Okay, so what we will do today is we will take a look on creating an own data type which can hold an arbitrary sized integer number. Um, those are useful in various scenarios. For example, if you want to do some cryptography, um, then you would need some sort of number representation which goes far past what the computer can normally represent. Since normally you can only go up to 64-bit, and in encryption everything at this bitness is pretty much useless. So even for symmetric keys, you should go at least with 128 bits. Um, and as soon as you go to asymmetric encryption mechanisms, then you need even more bits. I mean, RSA is a particularly negative example where you need, for example, for 4,000 bits to have any reasonable security. Elliptic curves are better. There, it's enough to have like 300. It was 384 bit keys for the same level of security. But it's still much more than what a computer can handle. So what is necessary is some data type which allows you to represent those numbers and to work with them in a efficient manner. So we will call it, let's say, myint or bigint. So bigint. Usually, if you Google, then bigint will be the name that will be typically used for such a data structure. Um, there are generally two strategies how those things can be implemented. One is that you just implement something of a fixed size that can go up to, let's say, 4 kilobits or any number that you have to predefine when you are creating the object, or you can implement it such that you can dynamically change the size of your object. So let's call this just main. Let's create a new header file um, for our number. Okay, I will connect the VNC so that you will be able to connect from far away. Just let me quickly check if this will be working. So ULP address at
Yeah, it
295.
works. I'm already connected.
Okay, perfect. Because sometimes it changes the local IP address, and then I need to update the routing configuration so that the computer is switchable from the internet. So okay. Do we want anything? Let's start with something simple. So the strategy will be that we need a constructor. So first task for today. Um, comma. Um, Create the container. Yes. So who wants to start first? Who was already connected?
Yes, I can do it.
Okay. So just start by adding the constructor, destructor, and then the two variables. The constructor should initialize the variable just both to 0, and the destructor should check if the data variable holds something non-null, and if it's not null, then delete it.
Unsigned int pointer, okay. Oh, yeah. That's fine. And what was it again? In the destructor, I should delete the.
You have
the
to
data,
delete
right?
mdata if it's not null.
But I think delete null is okay, right?
Yes, technically it will not complain.
Okay. Anything I forgot?
Okay, and the last part, what would be good to do will be to add a function to allocate something of a given size. So the function, so the function should take as argument a length parameter, which should specify. We can now select it, but let's say it should specify in bits how many bits the number should have, and then what it must do is it must allocate using the new operator a new mdata array of the size required. So you have to in principle just divide the length by 32, then check whether it is like you are missing a couple bits, so if there was some rest to the division, and if so, then add 1, and then allocate a new array of that size. Let's call the function alloc underscore data.
What's the biggest?
Just int length, for example, doesn't matter. Yeah.
So. Well,
you can use size of int.
Okay. not unsigned int?
Doesn't matter.
It's the
Assigned and
same, yeah.
unsigned is the same.
Okay,
Is the
now I
same
have
size.
to take care because division cuts off the residue,
It
right?
will
So
cut off the residue. Yes. So
I have to.
there are two ways how you can do it. One would be you can just multiply it again and see if the result is length. That would be like the cheapest way of doing it. Or you could use the modulo operation to see if there is a residue. So length modulo the size of int, and
Yeah,
if
right,
this is
I
not null, then you need to increment it by 1.
Let's do it like this. Okay.
I would add some brackets just to be sure that the thing will not do something in the wrong order.
Okay.
Just to be on the safe side. Perfect. And now we need to allocate it, and let's use memset to set it to 0, so that we have a nice empty data block.
I think I have to include this memory.h.
Yes.
Right. Okay. M0 size is new. No.
Very good.
All right, and we have to set our M size to.
Yes.
Oh, I don't need this.
You can use M size directly.
All right.
Okay, perfect. So then I would say this is it for the first assignment. The next assignment for our only other participant today will be to make a function which will print the content of the of mdata out as a hex string. So let me quickly make a few more changes and include something. So we want std let's use this notation to hex, and we need the content of the function, and what it shall do is it shall create a hexadecimal representation of the number and just return it as string. So Mr. Leon, would you like to try to do that?
Yeah, sure. Just have a question. So this size underscore t, this is an array, or what data type is this?
A size t is just a unsigned long, and the reason to use size t is that on different platforms this will always represent the maximal pointer size that you can use. So on a 32-bit Windows it will be 32 bits, on a 64-bit Windows it will be 64 bits, and on other platforms it should always be adapted accordingly. So if you program something for Arduino that has only 16-bit pointer size, then it would be, for example, 16-bit, and you don't need to to have special cases in your own code for the different compiler settings, etc. But the headers automatically are set up such that they will give you the right size t that you need.
Okay. So
so what you could do is for starters you could allocate a std string variable, which you then can return, and then in between you need something to fill it up. You can use, for example, the append function to add single characters to the string.
I'm sorry, I don't work so often with
Just double point and string, like the definition for the return parameter.
and now
That will not work. What you need to do is you need to make a loop that will go for every integer in our array, and inside this loop another loop which go for every single character in the integer, and then append every single hexadecimal character one by one to our string.
what did you say the second loop has to go over?
So our primary array is made up of integers, so every entry in our array are 4 bytes, 32 bits. So we need, and for every pair of hex numbers we need 1 byte. So you want here to go from for all of the bytes in our integer. So this will be a loop that goes from 3 to 0. And what we want to do to have the right ordering, we want to go from the end of the array. So not like above where you go from 0 to size, but we actually want to go from size -1 to 0 including 0. And in the second loop we want to go from 3 to 0 including 0, and then decrement the loop variable each time.
And why from 3 starting?
Because we want the right order. We want to have the highest. So in computers, you have two ways how you can encode your multi-byte numbers, and one is used typically in processors and also, at least in the typical ones like x68, ARM, etc. There are some that do it differently, but the normal method is that the first character in memory at the location of your number will be the one that contains the least significant bits. So in principle, if you are casting something to a smaller type, then you are just throwing away the higher bits and keeping the small ones, meaning that for small numbers it will work fine. And the other method of encoding is used often in network applications, because it's like more what you would expect if you would not think about practical considerations, where the first byte contains the highest order bits, and then so the order is always the same for all the bits, while And while in the encoding used by CPUs, you have every pair, every byte, like the order is simply swapped. Let me write down an example. So let's say you have a number, no, like 1 1 2 2 3 4 4, this number. So the way the computers would represent this in memory would be 4 4 3 3 2 2 1 1. So if you would cast this number to something smaller, then you can just take the smaller part or the even smaller part, and it works fine. While on the network, the bytes would be in different order. Oops. There's the mouse. Like this. And this is called big endian and little endian encoding. I always forget which one is which. Big endian is the one where you have the right order, so this one. And the one with the reverse order of bytes is little endian. And as said, the reason why this is used by CPUs is, I guess, just practical considerations that you can easier cast numbers if you just need to take at the memory address. So you can just cast, if you have a pointer to some larger number, and then you just decide that you will be using a smaller pointer, which would be not correct, then you can just take this number, but you don't need any special instructions or any additional calculations of offsets to get the number correctly. While if you would use big endian on the CPU level, then casting numbers would be more complex. At least, I mean, nowadays it doesn't really matter, but on very simple CPU architectures, everything you can save is worth saving. And what we want here is, we want, of course, when we print our number, to be printed correctly, like this. Yeah. So this is why we should, and here also I would say we should go with be consistent and just also go with the reverse order.
Okay.
What we then can do is we can create a 64-bit number, since we have a 64-bit Windows, and on it we can then see if we just copy the 64-bit number into the two integers, whether the printed out number will still be correct. Okay.
But what I still didn't get, so why the second loop?
So okay, let's go with it. So let's say we have a 64-bit number, 0x 1 1 2 2 3 4 4 5 5 6 6 7 8. So this is a 64-bit number, and this number will require 2 of our entries here to be stored. So we will need to this is equals new int 2. So if we then print this out from 0, is supposed to be the lower bits that goes up to here, and 1 will be the higher bits. Yep. And so the outer loop goes here like 0, first 1, then 0, and then the inner loop will go, so this thing can do something like, I don't know, char temp like this is equals like this, and then char 0 is equals no x automatic 1 2 3 what was next, 7 7 6 6 5 5. So the outer loop goes for these big entries, and the inner loop for every of those will go through the single bytes in our 32-bit integer. That's why we have this one. And what then you will need to do is, so each of those will again have like 2 single characters. So what we could do here is either we just push back single characters using append twice, or we allocate a small, very small C string with 3 entries, and then fill them up, and then use append to add. So we need 3 entries because we need one nibble, the second nibble, and then the terminating null, and then we can append it in one go to the string, what would be more efficient. So I would suggest that first thing what you do in the loop is write some code to get one of the individual bytes out of our data, and then we can look how we convert this to a hex string representing the 2 nibbles our byte is made out of.
Mm-hmm. I think I stehe auf der Leitung.
Sorry, what was the question? We just got a delivery. I needed to take care of that. Well, data from I, that is fine.
Follow, yeah.
And then you need to somehow get out of this. So now you get an integer with 4 bytes inside, and then you need to find a way to get every single byte here. And I wrote already some code in the example below, which you could use, repurpose reasonably easy.
Could we do it just with one loop by casting the array to a character?
You could do it with one loop, casting the whole array to a character. That would work, yes.
So this will take the first byte and the second, and the third, and so on.
Well, now you have the character. You need to take one of the characters from temp. Yes. So you could, for example, create a variable called current byte of type unsigned character, and assign it so that we have the character cached, and then we can continue with trying to make a hexadecimal string out of it. Yeah, I would not call it byte because byte is in some headers used as a type definition. Just call it current byte or car underscore byte or my byte, something like that. Yeah. Okay.
And now we just append it to the hex. No, we convert it into a hexa.
Yes, we need to convert it into a 2-nibble hexadecimal string. So I would suggest first to allocate a buffer of type character, which with 3 entries. I don't use alloc, just on the stack char buff in Klammern 3 in bracket 3. Sorry about that. Okay, and then we can assign the first buffer a value. So I would do it like this. You can assign it the lower order. Should we start with the lower order? No, wait. This one first. We need the higher order. You need to assign it the higher order nibble from our mybyte.
Mm-hmm.
You cannot access nibbles this way. You will need to use a bit shift operation, so shift the thing to the right by 4.
So the whole mybyte.
my byte, then bit shift operator to the right by 4. Okay, and now put this thing in brackets, and then just for good measure, end it with 0x0f. You don't need to cast it, just end it. I mean, in terms of end, like end and not end, like use the $ operator. End.
And what does this do?
No, that's the $. The end. Sorry, shifts X. It's a $ operator. We want the end operation, the logical end, not like end of something, but like end like A and B. Und. Yes. What it does is it clears all the higher order bits. So since we have since we shifted it, it should be filled up with zeros anyways. But for good measure, to ensure that there will be nothing that we don't expect, we just add this end operation. But at this point, our first entry in our buffer will only contain the numerical number that represent the nibble. It will not contain the actual character. And for it to contain the character from the range 0 till f, what we need to do is we will need to just add the character value of 0 if the contained number is below 10, and the character value of a minus 10 if the number is above 10. So you need to first make an if and check if buff 0 is less than 10. Okay, and if it's less than 10, then you just add to our buff 0 the character of null, of 0. Well, it must be the character, not the number 0. Yes. And if in the else case, you just add the character of a minus 10.
Yes?
No. Yes. And then you do the exact same thing just for the first nibble, which is easier because you don't need the right shift.
Okay, so, okay.
You can copy everything up to and including line 39. Yes?
And for the third, no.
Yes, for the third you just add a 0 to indicate that that's the end of our string. And once you've done that, you can add to our hex string using append the buffer variable, so it will add both nibbles to it directly. And not plus is like, just is like 0.
Okay, and for the others also, yes.
No, the others are fine. Here, for the second one, you just really want the null character, like not the null character, you want the terminating 0, so the value of 0, like really 0, 0, not the value of the ASCII character called 0, but just 0 as in einfach nur 0 drücken. Just press 0 on the keyboard. Okay. What you also could do, alternatively, is you can write it like this. But this just evaluates to 0. This is equivalent. Okay. Now you can add it using append to our hex string. Did you call it hex? Yes. And last thing to do is to return the hex value from our not here. Okay, then let me quickly test whether the thing works as it should. So we go to main, we include our big int. Okay, we should make this public, and for testing I will keep everything public. Okay, so we have our big int, my int, zack, alloc data 64 bits, punkt mdata, mdata, comma, reference m in, and let's go just test, comma 8. Could use actually so we said we tested with, where was it, this one, zack. Okay, and now we can try our function to hex, and that should work. Don't need hello world. Let's run it and see if it does what we want it to do. That is not good. Apparently the allocation function doesn't do what it should. Yeah, I gave it the right 64-bit. So let's put a breakpoint here and check what's happening. 16, that is not good. Why would that not work? Modulo 1, that should be fine. Perhaps it's something trivial like just brackets or something like that. Huh? Nope. Okay, then let's. So this should just give us 2. Huh? 4. Oh right. Size
4
of
bytes.
yes.
Bits times 8.
No, times 8. And for this one, we also should then just that this is times 8 here as well. No, oops. Now it will be working. The length is right, but the printing didn't work. Size -1. So let's put a breakpoint here just to see that it's definitely 2. Yes. And now let's start here. That should be. So I is 1. That should be fine. Temp. This is not right. Copy nach to data from test. Which unit we use for size? No, size is also correct. 2. The size is now in units of how many items we have. So this must be times 4 here. Yep, and it printed our number out correctly. Very good. So, the next thing we will need will be something to print the number also out as bytes. So, sorry, as bits, as individual bits. Let's quickly add a definition for this. To bin. But this maybe we will make as homework. today 27 01 2022. And the output should be then really it's the proper bitwise representation, nothing swapped, nothing changed. So it's reasonably easy if we take this as an example. And the next thing that would be good to have would be something that can read from a hexadecimal number. Maybe we do this today. Okay, and then we just make as the next part of homework also just reading from binary. That needs an argument. Okay, and now okay, the function from hex will have a return value of type boolean, which will indicate whether it managed to read the hexadecimal string, because someone could just pass a string with random letters which are not from the range that we require, and in this case we will return false, and if everything is fine we will return true. Oops. So maybe Mr. Leon again, since you made the 2-hex function, you could also try making the from hex function.
Okay.
So the strategy would be to first get the length, which you can just get with the, I think it's called size. Yeah, Punkt. Yep. And then once you have the length, you need to compute the length in bits, and then use the alloc data function which we have implemented above to allocate the right size buffer. Yep.
Okay. So what
So
we
you need to
want
do two things. First of all, you should check whether the mdata already contains something, and if so, delete it, or you can just delete it without checking. And then you need to use the alloc data function to allocate the new size for our new number.
to check if the M data contains something. So if it is a null pointer.
If it's not null, then delete it. You should use the mdata variable, not the size.
No, we delete if null.
Yes. No, if not null, you delete if it's not null, because if it's null, then it's already nothing. Then it's fine. But if it's already allocated, then you need to free this memory before you can reuse it for something else. Otherwise, you will accumulate a memory leak, and at some point in time, your program will crash. You should use the delete operator, since we use the new operator to create it. It's recommended to always use the same type of operators. If you would have allocated it with malloc, then you could use free. Delete, you just write delete. Delete square brackets, empty square brackets, because it's an array, and then just mdata. Okay. And in the next line, you can use alloc data. With the size in bits. Okay. And now you will need to read the string one nibble at a time and add it to our mdata.
Okay, so we have this
So the for loop wants semicolons, not commas inside.
Yeah.
And you should go to the length of the string and not to the size in bytes. So just you can either divide it by 8 or you just write bin string size again here. Oh wait, that should be called hex string. Sorry about that. I could just copy the bin string from the other example. Yeah, just change it to hex. And your size needs round brackets, since it's not a property but a function.
I think our m underscore size should also be used.
M size has been set by alloc data,
All right.
so we don't need to touch it at all.
Right.
Yeah, and here you will just take a character out of the string. You can use the hex string this. And there is also a .add operator which does the same thing. Not operator, function call, I mean. But it's fine to use the square bracket operator. It does the exact same thing, doesn't matter. Just assign a variable called char this value, so char ch is equals this. Okay, and now you will need to convert it from the ASCII letter-based representation to the actual binary value. So you just do the reverse of what you did at the beginning. Sorry, at the top.
So I have to check. I'm not sure I get what this function is supposed to do. So it reads this hex string and it returns.
One more thing. This should be 4, since every single entry. So what we want to do is, if we get a string like this, we want to convert it to a proper representation of this number in our M data. So to basically this thing. Or if we want to represent this correctly, we want it to be a byte array with this content inside in memory. So here, if you have your character, so this character will be, since we start at the top, will be this 1, and then you want to convert this to, so you want to do 1 converted to yeah, or if that would be f, then x null f. Basically you want to reverse this operation, undo it, so to say. You could create a variable digit in which you will write it. Sorry. In which you will write it, and the method is pretty simple. First, you check whether it's from the range 0 to 9, and if it's 0 to 9, then you just need to subtract 0 as a ASCII value, not as 0. And then you check if it's between A and F, in which case you subtract A plus 10. And then you do the same thing, but for capital A and capital F, since we want our function to be case insensitive.
Okay, but we get this as a char, so we need to convert this char symbol into the actual integer.
Into the digit, yes.
Is there a simple way to do this? Because I would just now write a switch, and so 0, 0, 1, 1, and so on.
Switch is too much work. You just use a if. So first you check. So the first if checks whether the ch variable is greater equals 0 in single quotation marks, and at the same time if it's smaller equals 9 in quotation marks. Greater or equal. Equal is also acceptable. That's not the right end. I know in some languages you write end as end, but in C++ for the end operation, if you want a logical end, almost. This is like bitwise. We don't want it bitwise. We want double end. Yes. Smaller or equals 9. Equals is also acceptable. So 9 is one of the values that are okay. And then you just can write digit is equals ch minus 0 in single quotation marks. Semicolon. Yes. And now you repeat that, but for the A to F and capital A to capital F range of values. And that's it. It would be recommended to use a else if, not just another if, but so to save on computation. If one of the ifs triggers, then we just don't need to do the other checks, because at any point only one of them can be true.
And this converts the ASCII value into an actual
number.
integer.
Yes.
This again?
Well, 0 will not be correct. You need to put something else than 0. Okay, and then you need to add something.
Add something. I have not a digit.
Well, currently, if you do this and the character is A, then digit will be 0. But A doesn't represent 0, but A represents 10. So you need to make plus 10, such that digit, if you have an A, will contain 10, and if you have an F, it will contain 16. 16, not right, 15. Yeah. And then you need to just copy the line and do the same thing just for non-capital A and F. I would actually insert the line in between, since no, sorry, it's fine. We are creating capital letters in our code, so it's better to test first for the thing we expect, and then just have a fallback in case it's a handwritten one. Okay, and then what we need as well will be a final else statement, which will just return false, meaning we abort everything and quit, because we found a character which is not a valid hex character, so something's wrong with the string. And now what we need to do is we need to add this digit to our mdata in the correct way. And it's not very simple, because it's just one nibble, it's not the whole byte. So it will not be you will always have 2 nibbles making out one byte in your dingsta, in your entry. Plus another problem, you will need to, we actually don't use bytes, we use integers, so actually it will be, you will need 8 nibbles to fill up one entry of data.
So it's not just we take this digit and
nope,
put it. Okay.
But you understand why?
I'm thinking, but I don't think I get it.
Okay, so our m data contains entries of this sort. And so on. And here, one character is just one single character out of this entry. So this will be 0, this will be 1, and you want, however, to set each of them individually. one by one by one by one. So first thing you do here is you will want to have a pointer on one of these entries. So that will be I divided by 8, and you can assign it to a unsigned in asterisk variable of type of type unsigned int asterisk of the name chunk, and then you will just need to take the address of mdata at this position. Okay, almost right. Int asterisk chunk is equals end operator. You need the square brackets, but you need the end operator because you want the address of from mdata. So if you use the square bracket operator, you always dereference your array. Yeah, and this way you will then still have a pointer to the array. So if you dereference chunk and change it, it will change the data in your array directly. Okay, now what we need to know is...
won't this be a float point number because E is an integer?
No, because it will just truncate what residue you might have. So the C language will never create you a float out of an integer unless you explicitly want it to, like by assigning some integer to a float or something like that. So if you divide, 0 till 7 will just be 0, 8 till 15 will be 1, and so on and so on and so on. Okay, and what you now need is you need to find out the exact offset in your chunk in bits where you want your 4 bits, your nibble, to go. So make a new variable of type size underscore t, call it offset, and calculate the offset.
Calculate the offset. So this will always be moved each time the for loop is executed. Will it?
Well, it will move in an increment of 4, and it will reset each time you manage to fill up. So every 8 iterations of your loop, it should reset to 0. Because for the next entry, next integer in mdata, you want it to start at 0 again. Yeah, that's well. If you want to do it this way, then you would need to have the offset variable located outside of the scope of the for code block. Otherwise, it will be discarded anyways. And you need to initialize it with 0.
Is there a better way to do this?
Yes, there is a better way to do it. I will show it to you once you finished your way.
And now I set the mdata, I think.
Well, not here, but after offset plus 4. Wait, no, you're right. You don't want to. Yeah, that's fine. So you need to go. So you just write. You want to access the memory where chunk points to. Well, you don't. I would just go with the chunk since you already have the right chunk. That you need to use the asterisk operator to dereference it. You don't want an address of the, and again asterisk chunk is, and then you can use the OR operator, the bitwise OR, to add your digit, and you need to bit shift it to the left by the amount that's in offset.
The chunk.
Yeah.
Needs to be bit shifted.
No, your digit has to be bit shifted. So the chunk is equals asterisk chunk, or yeah, that's quite wrong. So what you need is you need to use the OR operator to add the bits from digit to chunk, and the digits of your digit variable need to be bit shifted.
Okay, we want to add digit to chunk.
We want to use the OR operator to combine it with chunk. Yes, better. Chunk needs an asterisk in the beginning, but that's a minor detail.
And now we want to shift it.
Yes. Not the whole thing, just digit.
Just digit.
No, to the left. And I would put it in brackets just to be sure the compiler will do the right order. Not the whole thing, just digit and the offset. Okay. That should be working. Shall we try it out? Okay, so instead of using this, we can use now, hopefully from hex. Let's roll. The order. Wait, what? That is not working. Not even close to working. What did we scrap there? Let's think about it. What did we scrap? Let's see how it looks again. So we have some unallocated memory, we have some Fs, and the first two worked out fine. No, they also did not. The order is wrong.
So the loop has to count the other way?
That would be one way of doing it. Yes, the loop should go the other way around. But the problem is that then we will still want, if the whole loop goes the other way, then the whole thing will just do the same wrong thing in reverse. So we can do it here this more smartly. We take size minus I minus 1. Then we will get process the string from the back, but have the I still going up. That should already fix one issue. But as you see here, okay, we have this is fine, but the rest is still screwed up. So let's see why this is not working. Data I through A. Is that correct? That should be correct. Let's just make two loops through this. So first one will be 0. Yep, and the next go through it should also be 0. This is fine. This operates. Then it's 1. This works fine. So chunk should, let's see what our chunk will be doing. Clear. That is not good. That should have been initialized with zeros. Why isn't it? Let's see what we did here. So size. That should be right. Let's put a breakpoint here and see what we will see.
It's m size and then times 8, I guess, because we store the number of elements and not the
No, but this memset initializes, right. That will be a problem. Needs to be times 4. Okay, that should. Let's try whether that works now correctly. That might already be everything that was needed. Yep. And we write the number in as it was supposed to. Okay, and now about the better way of doing it. Need offset. Small t. And this should work as well. Yep. So what we do here is we just calculate the offset in just by multiplying I, and then just we use modulo to ensure that we will never exceed the range that of 0 to 31, which is the valid amount by which we can shift it, and we don't need a external variable for that. So this is an improvement. And if we would want to do it even differently, I mean, this is already a working solution. What one can do in principle is also to first blank those bytes out, so because here we are actually assuming that chunk will be full of nulls. This is full of zeros. This is why it didn't work when we did not have the initialization here. So if we comment the initialization out again completely, we will just get some garbage again, and we could implement this function such that we would not need those memsets. So what we can also do, we could do is chunk and end is equals the inverse of 0xf bit shifted, but we need to do this first. That should be working. Let's try quickly. Zack. Yep, works again. So what we are doing here in this operation is first we are taking 0x 1 2 f. Then we shift it. So what we will get is, for example, that depends on what offset is. Let's say offset is 4. Then we'll get something like this. And then we use the not operator to invert the whole thing. And then we use the AND operator here with chunk. So everything that is not f, or not 1 binary speaking, will be set to 0. So we clear the place before we set a new value to it. but since we want to have the thing initialized with zeros, anyways, we don't need to do this. Okay, and to finish up for the day, I would suggest whoever of you wants to create a constructor which will take a string and use our from hex function to initialize the string. And also what would be good would be to have three very simple helper functions. Get chunk count, which will return size, get size, which will return the size in bits, and is null, which will just check whether mdata is null or not. So who of you would want to implement that?
Well, I can do it.
Okay.
I mean, seems like today I've got the more easier parts. Sorry to Leo for that. Okay, so we want to have a constructor.
Yep. Works.
Okay. And we need some. What was the helper method?
Get chunk count, which will just return size, then get size, which will return the size in bytes, in bits, and is null, which will just check whether mdata is null or not.
All right. So number of elements.
Just so get chunks will just return m size. Yep.
Get bit count.
Yeah.
No, not again this mistake. So
yes.
Is it
8?
8. Yeah, 1 byte is 8 bits, right? And is null or is empty?
Okay. One comment about that. Here in the constructor, well, I mean, do we need to set this to 0? We don't need to set anything to 0. Yeah. It's fine, no comment. Usually it would be probably elegant to set the variables to 0 anyways, but since alloc data already sets them to a value, then it's fine. Yeah. What we could do as a small improvement of the whole design is that we move this functionality to alloc data. That it will check if it's null and then delete it, and in order for this then to work, then we would of course need here yeah, or what also works is just to call the other constructor from here. So this will do our initialization to nothing, and then from hex we'll read it. What would also be good practice is, because now if from hex returns false, we will silently fail, would be to throw some exception if this is not true.
Okay. I guess I can throw any object, right?
In principle,
C++,
yes.
so-
Yeah, you can write a character saying or a string. Yeah. Invalid formatting or something like that. I don't know. Or the most useless error ever, invalid parameter.
Sorry?
Or the most useless error message, invalid parameter. It doesn't tell you, just says it's not correct, but it doesn't tell you why it's wrong or anything. I mean, okay, there can be an even more useless error message which would just say something went wrong.
Mm-hmm.
But like from the ones that actually have a name, the invalid parameter is also one that does not often help you that much. Yeah, passed. I guess that's it for today, since we have only 5 more minutes. As I said, the homework will be to make the same thing just for a bit representation, so to bin and from bin. I will upload the lecture to YouTube, this file to the Moodle, so that you have it as a basis for making the homework, and the homework entry to the Moodle as well. During the next lecture we will continue on our integer. Since our integer cannot do much yet, we will add a bunch of operators, which will allow us to do nice things like addition, subtraction, division. Division is difficult, but we can do it. And the nice thing about how this is implemented is that it allows us to test our implementation with a we can write something that will automatically test the operation, and as a benchmark for what should be the result, we can just use a 64-bit integer. What we could do also would be we could change in principle this thing to be a template, and instead of int be able to operate with any size of underlying data type. And then we could, for example, have it use shorts, and then we could test even scenarios where we have four entries in our array without much difficulty. Of course, you can write like synthetic tests where you just write, okay, I write 2 numbers, I make the addition by hand on paper and write out the result. But for automated tests, it's of course best if we have something against what we can benchmark it without having to do too much own work. Yeah, that's that. I guess we'll see each other in 4 hours from now. No, 3.5 hours from now, and yeah, if there are any questions you can ask at any time. So bye bye.
Thank you. Bye.
Bye.